Hi, let me tell you about another great Manning book, AI Agents in Action, 2nd edition. Intelligent Workflows with LLMs, MCP, A2A, and more, written by Michael Lanham.
The term agent is frequently conflated with mere automation, but true agency represents a fundamental architectural shift, the capacity of an entity to reason, plan, and execute tasks on behalf of another without constant supervision. We are moving beyond the era of the chatbot, a passive responder, to the era of the autonomous worker. The failure state in modern AI development is remaining a prompt tinkerer rather than evolving into an agent architect. If we fail to distinguish between a human-in-the-loop assistant and a truly autonomous agent, we build brittle systems that require constant user approval, effectively negating the efficiency gains of AI. The goal is to build systems where agents act independently to earn their keep in production environments. To architect these systems, we must first delineate the boundary between the assistant and the agent. An assistant functions as a proxy. It reformulates requests and identifies tools but remains tethered to a linear approval chain. It must ask the user, "Is it okay to execute this function?" In contrast, an agent possesses the agency to execute the decision loop autonomously. It receives a high-level goal, such as filter my emails, and independently determines the necessary tool chains to execute that goal without intermediate human sign-off. This shift from reformulating requests to independent decision logic is the critical leap in system design. The internal mechanism powering this autonomy is the sense, plan, act, learn loop. Unlike static code execution, agents decompose abstract goals into tool-level tasks through a recursive cycle. The agent senses input or feedback, plans a series of tasks, acts by executing tools, and learns by observing whether the tool output aligns with the goal. This loop allows the agent to dynamically revise its plan if a tool fails. For example, no flights available, rather than halting execution. Classically, giving agents the ability to act meant tightly coupling tool code within the agent's codebase, leading to fragmentation and fragile integrations. The solution is the Model Context Protocol, MCP, essentially the USB-C for LLMs. MCP uses JSON RPC 2.0 to standardize how agents connect to external tools, decoupling the client from the server. By querying list tools, an agent can dynamically discover capabilities, whether local or remote, solving the issues of inconsistent error handling and hard-coded integration fragility. Robust agent architecture requires a layered approach. At the base is the persona, system prompt, followed by actions and tools, the MCP interface, reasoning and planning, logic strategies, knowledge and memory, RAG, databases, and finally, evaluation and feedback, guardrails. Each layer hardens the agent against hallucination and execution failure. When single agents hit performance ceilings, we scale horizontally onto multi-agent systems. The agent flow pattern mimics an assembly line, passing context sequentially for high control. The orchestration pattern uses a hub-and-spoke model for central delegation. While collaboration, peer-to-peer patterns offer high problem-solving potential, architects must be wary. These systems can become chatty, computationally expensive, and repetitive without strict role definitions. By mastering the sense, plan, act, learn loop and implementing the Model Context Protocol, we resolve the dependency on human intervention. We transition from building passive assistants to deploying autonomous agents capable of navigating complex workflows. The transformed state is an architecture where agents act as reliable digital workers, capable of connecting to any data source via MCP and executing multi-step plans with resilience. Start your implementation by defining the core functional layer of your first agent.
Get this book at Manning.com